So what I want to go over tonight is calculating some ventilation requirements. All of this stuff is out of chapter 4 in the book, and it's pretty much the only thing on your exam where you have to do math and you kind of have to think about it a bit. Most of the things um, is just straight out of the book. Like if you can find the section about what it's asking you a question on, you should be able to just, transpose an answer to that sentence and you'll be done with it. But with ventilation, you actually have to know how the process goes. And really, the only thing you need to be able to do well is the first half of calculating ventilation air, because there's things that go into um, where you're at in the breathing zone and what type of system you have and this and that are involved in it too, and we'll talk about that at the end. But mainly just want to make sure you understand how to use the table in chapter 4 and how to calculate ventilation air with only a couple pieces of information. You only need a couple pieces of information so that you can calculate how much ventilation air is required in a building or a space. So if we look through chapter 4 here, there's information on intake opening locations and intake opening protection. We can talk about these in another class. They're things we want to go over. Um, but the and then there's things on natural ventilation that you'll want to look at. But mechanical ventilation, section 403, is the real important part here. All right, and we're going to talk about these airflow rates. So the minimum ventilation rates are in table 403.3.1.1, and that's this table right here. Now what I've done is I've taken this table and I've created a little document right here for us to look at so that it's all kind of in one spot a little bit better. So you look at this table in your book and then go to the end. At the end right here, down here. At the end of this table there's a bunch of notes, and I want to talk about these notes first to make sure that you've read them, and then we'll talk about how to use this table. Alright, the equation and how to use this table. This equation, as a matter of fact, let's go back to the thing real quick. This equation is after the table, after the notes, and it says the minimum outdoor air required to be supplied at each zone shall be determined as a function of occupancy classification and space air distribution effectiveness in accordance with section, and this is ridiculous, but it's 403.3.1.1.1.3. Alright, I didn't make these sections. So anyway, and that's equation 4.1. So we're going to talk about that equation. But looking at the table, the first thing you want to do in any table in the code book, if you ask me, is make sure you read all the notes. Read all the notes. So that way when you see these letters, right? When you see these letters right here, you know what that letter means in the notes because it's important. Alright, so the floor area is based on net occupiable floor area. So that means if there's an area in the space that really isn't occupiable, it's a storage closet or something like that, it doesn't count. Alright, mechanical exhaust required and recirculation of air of such spaces is prohibited. Recirculation of air that is contained completely within such spaces shall not be prohibited. See section 403.2.1. This is for certain spaces where you have to provide exhaust and you can't recirculate the air. So that's what note B is. Note C is spaces unheated or maintained below 50 degrees are not recovered by these requirements unless occupancy is continuous. So if you see note C, that's where you're at. Note D is ventilation systems in enclosed parking garages shall comply with section 404. So if you're dealing with an enclosed parking garage, you'll want to calculate it based on section 404. E is for bathrooms, and rates are per water closet in urinal. So you'll see this under the exhaust side, and we'll look at that, but those airflow rates are per water closet or urinal. The higher rate shall be used where the exhaust system is intermittent. So the higher rate is used when the exhaust only comes on when there's people in the bathroom or the light switch is turned on or something. The lower rate is permitted where the exhaust system operates continuously while occupied. So if the exhaust system basically runs the whole time the building is occupied, you use the lower rate, and we'll talk about that specifically. For F, rates are per room unless otherwise noted. The higher rate shall be provided where the exhaust system is designed to operate intermittently. The lower rate shall be permitted where it operates continuously. This is for kitchens and things like that, if I recall, but that's note F. Note G is mechanical exhaust is required and recirculation of from such spaces is prohibited, except that the recirculation shall be permitted where the resulting supply airstream consists of not more than 10% recirculated air. Recirculation or air that is contained completely within such spaces shall not be prohibited. So you can have up to 10% recirculation or only recirculation of air in that particular room for note G. And note H is for nail salons. Each manicure and pedicure station shall be provided with a source capture system. So that is an exhaust close to where the manicure and pedicure stations are, and they have to be capable of exhausting not less than 50 CFM per station. Exhaust inlets shall be located in accordance with section 502.2 or 20, and where one or more such required source capture systems operate continuously during occupancy, the exhaust rate from such systems shall be permitted to be applied to the exhaust flow rate required in table 403.3.1.1, which is this table for the nail salon. So those are all your notes. All right, all those notes are important. You want to make sure you look at those, and again, any table you're dealing with out of the code book, you want to make sure you've read the notes because there's important information in there. With that being said, this table tells you how much airflow and how many people there are in a building where you need to occupy the air. So in a building where you need to provide outdoor air. So the outdoor airflow rate required in the breathing zone, so where the breathing zone, there is a definition on that. It's basically, the breathing zone is basically the area where you expect somebody's head to be located. So about 6 foot above the floor, in the building, in the occupied space. So you can look up the exact definition of that in your code book. Look up breathing zone and it'll tell you exactly how they define the breathing zone, but it's not that important for the purposes of this class. The most important thing is being able to use this equation. So the equation is the ventilation air to the breathing zone. So VBZ, so ventilation to the breathing zone, equals the rate for people, RP, people outdoor air rate, right, times PZ, the number of people in the zone population, plus RA, the rate for the area outdoor rate, times AZ, the zone floor area in the zone. All right. So you need those 4 pieces of information to do the equation. All right, and here's the equation written out the way I think about it. VBZ equals RP times PZ plus RA times AZ. So the parentheses are there because you'll do this section, right? And then you'll do this section, and then you'll add them together. Alright, so where do you get these numbers? Well, the rate for people and the rate for the area are given directly in this table here and here. And they even stick the little variables. They even put the designation for the variables right there and there. So RP is right in the second column of the table, and RA is the third column of the table. So those, you just plug those numbers straight in based on the building type. So if we're talking about a correctional facility, in the actual, well, no, let's not do the cells. In the booking waiting, so the first thing, the booking waiting area in a correction facility. So whatever is the booking waiting area, however big that is, the RP for that area you're going to get right here, and the RA for that area you're going to get right here. So you just plug this number in here and this number in here. Alright, so those are easy. You have to figure out the number of people in the zone. Alright, so for people in the zone, you divide the square footage of the space by 1,000 and then multiply by the occupant density. The occupant density is right here. Alright, so there's your occupant density. Our occupant density is 50 per 1,000 feet. So if this was 1,000 square foot space, there would be 50 people in it. If it's a 1,500 square foot space, there'd be 75 people in it. If it's a 2,000 square foot space, there'd be 100 people in it, and so on and so forth. And whatever that number turns out to is what it is, and I always round up. You always assume, if you end up with like 4.3, well then there's 5 people. And then the area of the zone is given. So this is really the only piece of information you need. What type of space it is, and what's the area of that space. If you've got those two pieces of information, you can figure everything else out. All you need to know is what type of space it is and how big is it in square feet. If you have that, all the other numbers can be figured out. Alright. The last column right here is for exhaust, and you'll notice a lot of them have no requirements, but some of them do. So we'll do an example with those two, but the exhaust is separate from the ventilation air. But notice that this is chapter 4 ventilation, but there's a lot of exhaust requirements that are in ventilation. So if you need that information, you get it out of chapter 4. Chapter 5 is specifically exhaust, and there's a lot of information about like kitchen exhaust and things like that in chapter 5. But chapter 4 is like environmental exhaust, so exhaust for bathrooms, exhaust for kitchens, exhaust for particular types of spaces. You actually find that in chapter 4, and that's one important thing to remember about chapter 4. Is if you have environmental air exhaust requirements, then you will generally find that in chapter 4. So with that being said, I want to do a couple examples here, and we'll hopefully be able to work through this table a lot better after we do an example, because really that's the only way to kind of wrap your head around it, is to do some examples. And these examples are going to be fairly similar to what you see on your exam. So as long as we get these examples done, it shouldn't be too hard. Alright, so let's switch over to a couple examples here. Alright, and I'll leave the equation at the top of these examples so that they're sitting there the whole time, and you'll see it. What we're going to do is we're going to fill out each part of this equation, and I highly recommend you do this like this. When you take your actual test, you'll be able to have a scrap piece of paper. So I recommend you go to section 4.1, write down this equation, and then fill in each part of the equation so that when you're done, you can just walk through everything in the equation. Alright, that way you can just do it all in one go, and you'll be good to go. So example, what is the required airflow rate in a 2,500 square foot smoking lounge? So right off, we know the area of the zone, right? So AZ becomes 2,500. Easy peasy, right? You can automatically fill out AZ. Area of the zone is 2,500 square feet. Okay, how many people are in the zone? Well, we got to go back to our table to look at how many people are in the zone. So let's go back to our table. All right. Let's look for a smoking lounge. No smoking lounges. And sometimes the same thing is in multiple places. So you just want to kind of look. So far, oh, there's one. There's smoking lounge. There may be other ones, and sometimes it's important what kind of building it is. So this is a smoking lounge for an educational facility. Public spaces, here's another smoking lounge, but if we look at it, we should see that the numbers are the same. Smoking lounge is 7060, smoking lounge is 7060. B, mechanical exhaust is required and recirculation from air from such spaces is prohibited. But anyway, we see smoking lounges, it's 70 people per 1,000 square foot, 60 CFM per person, no CFM for the area, and exhaust, it doesn't give us a number. So if we go back to our equation, all right, we'll go back to our equation here. The required rate for the area was 0. That was the third column, right? And there's nothing in the third column. So we have 0 times 2,500 right there. So that'll be easy. The rate of people was 60, right? It was 60 CFM per person. Let's go back and look real quick. Let's go back and make sure we have this right. The number of people per 1,000 square foot, the first column is 70, so there's 70 people per 1,000 square foot, and for each person we need 60 CFM. So switching back, it was 60 CFM per person, and then the number of people in the zone was 70 per 1,000 square foot. So here's the first bit of math we actually have to calculate. We have to do 2,500 divided by 1,000, right, is 2.5. 2.5 times 70, because there's 70 people per 1,000 square foot, will give us 175. So we put that number here, 175. So we have 60 CFM per person times 175 people plus 0 CFM per square foot times 2,500 square foot. So this equals 60 times 175. 60 times 175 is 10,500. Oh, 10,500 plus 0 times 2,500 is 0. So our answer equals 10,500 CFM. We have to have 10,500 CFM of outdoor air for a 2,500 square foot smoking lounge. Now, obviously, most smoking lounges aren't going to be 2,500 square feet. But if we had one that big, it would need an awful big makeup air unit. Okay? So that's one where we don't have any requirement for outdoor air for the area. We have one for each person, but we don't have any requirements for people. And it's important to note that that's 70 people per 1,000 square foot. That can't be changed. So even if the plans say, it's only meant for 5 people to occupy that area, you always calculate the outdoor air as if you've got the density as required in the book. So that is where you get the occupancy for the space when it comes to outdoor air. You don't get it from the actual occupancy of the building. All right, what's the required outdoor airflow rate for a 5,000 square foot museum? Well, again, we can just put in 5,000 square foot right out of the gate, right? That's the area of our zone. Our zone is 5,000 square foot. So now we need to go back to our table and find a museum. So if we look around, we don't see any museums, right? No museums, no museums, no museums. So go over here. No museums. Offices, no museums. Private dwellings, no museums. Public spaces, here we go. Museums, right? So we have museums and galleries right here. There's also children's museums, museum children's, but the question didn't say anything about children's museums, so I will assume that they meant regular museums. All right. So regular museums, it's 40 people per 1,000 square foot, 7.5 CFM per person, 0.06 CFM per square foot, and then no exhaust requirements here. So let's see if we can't fill that stuff in. So the first thing I do is I fill in the rate for, before I did the rate for the area first, right? So let's do that first. The rate for the area was 0.06. That was the third column, right? The rate for the people was 7.5. That was the second column. The number of people in the zone was 40, right? Did I switch back over? I didn't. Sorry. Switch back over. All right. So let's explain that again. So the area we already filled out. The rate for the area, that third column, was 0.06. The rate for each person, which goes here, is 7.5. So 7.5 went right here, right? You see it? 7.5. That's the rate for each person. And the number of people in the zone was 40 per 1,000 square foot. Well, we have 5,000 square foot, right? So 5,000. Oh, it's a little bit bigger than that, isn't it? Let me, there. You see the calculator a little better now. Alright, so let's clear out that calculator. 5,000 divided by 1,000 is pretty easy, right? That is 5 thousands. 40 people for each 1,000 square foot, so multiplied by 40 gives us 200. So 200 is the number of people in the zone. Done. Alright, so now we can finish out our equation. 7.5 times 200. 7.5 times 200 is 1,500 CFM because of how many people are in there. Alright. Plus 0.6 times 5,000, or 0.06, sorry. 0.06 times 5,000 for the area of the space is 300. So 1,500 plus 300 equals 1,800 CFM. Alright, go ahead and move that down. 1,800 CFM. So for a 5,000 square foot museum, you would need 1,800 CFM of outdoor air to the breathing zone. Do a couple more. What is the required ventilation rate for, let's put public so that we can be specific here. For a public bathroom with 5 toilets, and as a matter of fact, I shouldn't put ventilation. Let's fix this question. What is the required exhaust airflow rate for a public bathroom with 5 toilets where the fan operates intermittently? So if that's the question we got. We actually aren't even going to use this equation. The only equation we need is the exhaust rate times the number of toilets. So this is a little different, right? But you'll see questions like this on the exam, so I want to make sure you got it. So any public bathroom, to figure out the exhaust rate required for the bathroom, you're just going to need to know the number of toilets or urinals and the exhaust rate for those bathrooms. Okay, so if we go back to our table real quick, we need to find a public bathroom. So there's a lot of them here. All right, there's one right here in our public spaces, toilet rooms, public, and there's our rate, 5070. And I'm sure if we look around, there's a couple more instances of it, isn't there? Oh no, there's only one instance in the table. I lied. I could have sworn public toilet rooms had more spots. So public toilet rooms is right here under public spaces, right? Public toilet rooms. Let me center this up for you, make this easier to read. So public toilet rooms, it says 5070 and our note is E, right? So in toilet room public, we don't have anything to fill out our equation, so everything is basically zero, so it doesn't matter. But we do have an exhaust requirement in the fourth column of 50 and 70. So if we remember our notes, go over here to our notes. For note E, rates are per water closet or urinal. The higher rate is required when it's intermittent, and the lower rate is required when it is continuous. So that's right there, note E. So if we go back to our equation, we had 50 and 70, right? So we can fill out what airflow rate we're going to need for that public toilet room quite easily. All right. So the exhaust rate is 50 or 70. But which one is it? Well, the higher rate is when it's intermittent and the lower rate when it's continuous. And since we see intermittently there, we can say, okay, well, it's not 50, it's the 70 times the number of toilets. Number of toilets is 5. All right, and I'll go ahead and darken this up and make it bigger so we're focusing in the right spot, right? Exhaust for the number of toilets. Exhaust rate times the number of toilets is 70 times 5. So that means that 70 times 5 Alright, 70 times 5 is 350, right? So we need a fan, an exhaust fan, that can do 350 CFM. So we'll have to size our ventilation fan and our duct for a bathroom with 5 toilets that operates intermittently, so it can do 350 CFM. Done. That's how we do bathrooms. Bathrooms are pretty simple, and it's just the exhaust rate times the number of toilets for bathrooms. Alright, what is the required airflow rate for an art classroom? I never finished this one. That is, let's go, let's make this one a little different. Let's go 2,300 square foot. Most of my questions, I make it nice round numbers. Let's do 2,300 square feet. Alright, so an airflow rate for an off art classroom, that's 2,300 square feet. So let's pull our equation here again. Put our equation in there so we can see it. Art classroom, that is 2,300 square feet. I'll leave the equation there and we'll fill it out again. So number 1 is the area of our zone, right? The area of our zone is 2,300 square feet. AZ right there, done. Alright, the rate for the area, we can fill that in, right? Let's see if we, well, first we got to find it, right? We got to find where we're at in our table. So let's look at where we're at in our table. art classroom. Well, if I had to guess, that should be under education, right? Education. Oh, there we go. Art classroom. So art classroom's right here. Let's draw ourselves a nice rectangle around it so we can see. There's 20 people per 1,000 square foot, 10 CFM per person, 0.18 CFM for each square foot, and 0.7 CFM exhaust, right? 0.7 CFM exhaust per square foot, right? Because the exhaust airflow rate up here, unless there's another note, the exhaust airflow rate here is actually per square foot. So let's figure all of that out. What kind of ventilation do we need for an art classroom? All right, so our airflow rate, I gotta switch you over. So 20 people per 1,000 square foot, 10 CFM per person, 0.18 per square foot, and then 0.7 per square foot exhaust. So let's fill in everything there so we've got it. Alright, it was 0.18 CFM per square foot. It was 10 CFM per person, right? 10 CFM per person. The number of people in the zone is 20 per 1,000 square feet. So 2,300 divided by 1,000 is 1.3 or 2.3 times 20 is going to give us 46 people. 46 people. Alright. So 10 times 46, we don't even really have to do, well, I'll do it anyway. 10 times 46 is 460, right? Unless I'm crazy. 460 plus 0.18 times 2,300. 0.18 times 2,300 is 414. So 414 plus 460 plus 460 equals 874 CFM that we need to the breathing zone. And we also had an exhaust requirement, 2,300 square foot times 0.7, right? We had a 0.7 exhaust requirement. So we also need to have an exhaust fan for that art classroom that is capable of providing 2,300 times 0.7, 16, was it 0.7? It was. It's got to be capable of providing 1,610 CFM. So we actually need more exhaust air than we have ventilation air. So we're probably still going to need more makeup air because you want to keep the space neutral. So you'll actually need more makeup air somehow than exhaust. But as long as 874 CFM gets to the breathing zone, the rest can get to wherever, right? So this is 1,610 CFM is the exhaust requirement. 874 CFM is the minimum outdoor air requirement for the art classroom. And it's pretty much as simple as that. As long as you can push out that equation for any space that's however many square feet, you're good to go. With that being said, let's go back to our chapter and discuss what else can be involved here. So after you have those numbers, and that's all you really need for your test, so just remember that there. As far as math, they don't really make you take into account the rest of these factors, but you want to understand them. So the next thing in that chapter is about zone air distribution effectiveness, and this is how well your air handling system provides that ventilation air to the breathing zone. So if you have a ceiling or floor supply of cool air, then its effectiveness is 1, which means it's 100% effective, so you're good, right? A ceiling or floor supply of warm air and a floor return is 1. It's 100% effective. A ceiling supply of warm air with a ceiling return is 0.8, so it's only 80% effective. Floor supply of warm air and a ceiling return is 0.7. It's only 70% effective. All right. Makeup air drawn on the opposite side of the room from the exhaust and or return is 80% effective. And makeup air drawn in or near to the exhaust and or return location is only 50% effective. So this effectiveness is what determines how much air you really have to provide, because you take the zone outdoor airflow rate, right? The zone outdoor airflow rate, so the actual amount of outdoor air your equipment needs to do, is the ventilation to the breathing zone, so this is the number we just figured out, divided by the zone air effectiveness up here. So say for that art classroom, okay, we had a floor supply of warm air and a ceiling return. So if for that art classroom it had a floor supply of warm air and ceiling returns, we would have a 0.7 effectiveness. So our outdoor air requirements was 874 CFM, right? So we would divide that 874 by 0.7, and we would get that we actually need 1248, basically 1249 CFM of air, because only 70% of that air is going to actually get to the breathing zone. So we need to provide more ventilation air so that we actually get that outdoor air to the breathing zone. And that's what zone air distribution effectiveness is all about. And that is the next step of your equation. All right. And then the system outdoor airflow is all about whether, like how you're providing it. So the outtake air, the outdoor air intake rate, okay, is determined in accordance with 4.3 for single zone systems. So the outdoor air intake just equals the zone outdoor airflow rate as required. All right, so that is, it's basically, this is the last part of your equation at that point, because you've only got a single system. For if you have a 100% outdoor air system, it's the same thing. Basically what you came up with at the end is for all the zones. So if you have multiple zones where you're doing one unit, then you have to, your outdoor air intake rate has to be the ventilation for all your zones. All right. And then for multiple zone recirculating systems, you have to, the outdoor airflow rate supplied to the zone from the air handling unit in which the outdoor air intake is located. You got to figure it for each zone. And then the system ventilating efficiency is based on this table, all right, the EV up here. So what it boils down to is there's other factors you need to take into account to get all your outdoor air intake rates right. But for the most part, most systems are just going to be, after you get this zone air distribution effectiveness done, then that'll be your outdoor airflow rate. And I pulled up a table here. If you ever have to actually do this outside air ventilation rate, this is how the engineers laid it out. So this is for an actual building, an actual job, right? What they'll do is they'll put the area there, the occupant density, right? So based on the area, how many people are in there. So since this area is only 84 square feet, a lot of times that's going to be 1. So you've seen that. And then the zone population, which is based on the occupant density, the people rate, that's required, which we did, the area rate, which required, what we did, the sum of RA and AZ, 5.04, the sum of the zone area times the people in the zone there, the ventilation required to the breathing zone, the zone air distribution effectiveness, the actual ventilation air required, the supply air required to the breathing zone, and then, ZP and EV, which I can't even remember now. But anyway, the point is there's actually better examples of this table, but here's one example of how an engineer laid this out. What is ZP and EV? Let's go back because I forgot already. The zone population? No. What was ZP? ZP. EV was the system ventilating efficiency, which is basically another correction for the effectiveness, right? So it would increase the amount again, and the ZPO is the primary outdoor air fraction. So, making sure you have enough outdoor air versus primary air. So, yeah, those are all the things you would actually have to take into account to do that, which, like I said, we didn't really go over anything past the distribution effectiveness here. But for most places, it's going to be 1 anyway, if you're going to be calculating it, and the code doesn't really require you to go farther than that. So part of why I don't know this like at the back of my hand is because I don't have to do it that often. You don't need to be able to do it to pass your test, but if you really want to do this stuff, that's the last few things that you'll need to go through in the table. But for the purposes of your exam, if you can get at least get this far, you're in pretty good shape, and if you can get these last 2 numbers, you're golden. Alright, and then everything else is for actual submitting to plan review and stuff. You won't need to do it unless you're going to actually design commercial buildings, so I wouldn't worry about it too much. So that is calculating outdoor air for any building or zone. Basically, as long as you know what type of zone it is and the square footage of the zone, everything else just comes out of table 4.3.3.1.403.3.1.1. I wish they would just call it table ventilation air because it's such a long section number. But anyway, table 403.3.1.1, as long as you got that, everything else comes straight after, no big deal. Have fun on your exam.